Now in this lecture we find out the perimeter of quadrilateral ABCD. In the drawing we have quadrilateral ABCD. Those two angles, they are both right angles. This is angle PQC, this is also a right angle. This is line segment PQ, this is equals to 20 units in its length. This is line segment BQ, this is equals to 10 units in its length. This is line segment QC, this is equals to 40 units in its length. Again, our task is to find out the perimeter of this quadrilateral ABCD. So, what is the definition of a perimeter? The perimeter of quadrilateral ABCD is equal to the sum of its four side lengths. That is to say, the perimeter of this quadrilateral ABCD equals to AB plus BC plus CD plus DA. So first of all, we have to find out the perimeter of this quadrilateral ABCD. So first of all, we will do a construction. That is to say, we will draw perpendicular on AD at point P. Again, at point P, we will draw perpendicular on AD. So this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We'll extend the perpendicular from point P on AD until it touches side BC. And we define the touching point of the extended perpendicular from point P and BC. This point is point M. Those two angles are defined as one-sided and interior angles. The sum of those two angles, it is 90 degrees plus 90 degrees, is 180 degrees. So here we can implement rule 18. According to rule 18, if the sum of two one-sided interior angles is equal to 180 degrees, exactly like here, then they are located between parallel lines. That is to say, those two angles are located between parallel lines. That is to say, AB is parallel to PM. So repeat quickly on rule 18. According to rule 18, if the sum of two one-sided interior angles is equal to 180 degrees, then they lie between parallel lines. In the drawing we have those two one-sided interior angles, alpha and beta. So if alpha plus beta equals to 180 degrees, so if the sum of those two one-sided interior angles equals to 180 degrees, then they are located between parallel lines. That is to say, line A is parallel to line B. So we can implement rule 18 in our drawing, right? Because in our drawing, we have the sum of those two one-sided triangles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to PM. So write it down according to rule 18, because of the fact that the sum of those two one-sided triangles is equal to 180 degrees, they must be located between parallel lines. That is to say, AB is parallel to PM. AB is parallel to PM according to rule 18. Likewise, the sum of those two one-sided interior angles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, PM is parallel to DC. So according to rule 18, PM is parallel to DC. Likewise, the sum of those two 180 angles is equal to 180 degrees, and therefore must be located between parallel lines. That is to say, AB is parallel to DC. AB is parallel to DC. So in total, we found out that AB is parallel to PM. PM is parallel to DC, and AB is also parallel to DC. So those three line segments AB, PM, and DC, they are parallel to each other. Because of the fact we have here three line segments, that is to say AB, PM, and DC, that are parallel to each other, and those two three line segments AB and PM and DC that are parallel to each other, they are connected together by line segment AD and line segment BC. Again, line segment AD connects the three parallel lines together. Likewise, line segment BC also connects the three parallel lines together. As you can see here, BC connects the three parallel lines together. So, according to the basic proportionality theorem, whenever you have three or more parallel lines, whenever three or more line segments are parallel to each other, like here AB is parallel to PM and is parallel to DC, and we have two line segments that are not parallel to each other, and they connect the three parallel lines together, like here AD connects the three parallel lines together, and BC also connects the three parallel lines together, then a special relationship exists between the two lines that are not parallel to each other. That is to say, a special relationship exists between AD and BC that are not parallel to each other. The relationship is as follows. According to the basic proportionality theorem, a special relationship exists between AD and BC. Those are the line segments that connect the three parallel lines together. The following relationship exists between AD and BC. AP over PD, AP over PD is equal to BM over MC. Equal to BM over MC. And again, because of the fact that we have three line segments that are parallel to each other, AB is parallel to PM and is parallel to DC, and we have two line segments that connect the three parallel lines together. AD connects the three parallel lines together, and BC also connects the three parallel lines together. So according to the basic proportionality theorem, a special relationship exists between AD and BC. The relationship is as follows. AP over PD equals to BM over MC. Again, AP over PD equals to BM over MC. It is given as a question that AP equals to PD. So if we define the length of AP as x, then the length of PD must be also equal to x because they are equal to each other. So here we have AP over PD equals to BM over MC. AP is x over PD. PD is also x, so it is AP over PD is x over x equals to BM over MC. X over x is 1, so 1 equals to BM over MC. Here we multiply this equation by MC, and finally we get that MC equals to BM. So in total we found out that BM equals to MC. If BM equals to MC, it means that point M bisect BC. Again, BM is equals to MC, and therefore point M bisects BC. The first half of BC is BM. The first half of BC, of course, equals to the second half of BC, that is MC. And each half must be equal to BC over 2. Again, each half, BC and MC, each half must be equal to BC over 2. So BM equals to MC, and each half, the first half BM equals to the second half MC, and each half, of course, must be equal to BC over 2. But what is the value of BC in total? BC in total equals to BQ, that is 10, plus QC, that is 40. So in total, BC equals to 10 plus 40. BC equals to 10 plus 40 over 2. 10 plus 40 is 50, and 50 over 2 is 25. So in total, we found out that BM equals to MC equals to 25. So BM equals to 25 units in its length. Likewise, MC also equals to 25 units in its length. And according to what is given in the question, QC equals to 40 units in its length. In the next step, we define this angle QPM as alpha. So in the right triangle PQM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we will do another construction, that is to say, from point M, we will draw perpendicular on DC. Again, from point M, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We'll define the touching point of the perpendicular from point M and DC, this point is point M. By doing this construction, we get here quadrilateral MNDP. Inside quadrilateral MNDP, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral PMND, we have 4 angles, and therefore quadrilateral PMDN is a rectangle. We have rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. BC is one side of quadrilateral ABCD, so BC is the side of a quadrilateral, it is absolutely a straight line. So if we focus on the left side of the straight line BC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the left side of BC at point M? We have 90 degrees minus alpha plus 90 degrees plus the missing angle, in total must be equal to 180 degrees according to rule 3. 90 degrees minus alpha plus 90 degrees is 180 degrees minus alpha. So 180 degrees minus alpha plus the missing angle, in total must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to alpha degrees in its side. Why? Because 180 degrees minus alpha plus alpha is 180 degrees. That is the sum of the angles of the left side of the straight line BC at point M according to rule 3. Therefore, this missing angle must be equal to alpha degrees in its size. So in the right triangle MNC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this from this angle must be equal to 90 degrees minus alpha. 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. In the next step, so we found out that BM equals to 25 and MC also equals to 25 because at point M, BC is being bisected into two halves. The first half, BM is 25, and the second half, MC also equals to 25 units in its length. So in the next step, I will copy the right triangle PQM and this right triangle MNC in a new page, and we will prove that those two right triangles can go into each other according to angle side angle rule. This is the right triangle PQM. Now, before that, we will implement the Pythagoras theorem on this right triangle, triangle PQM. So copy the right triangle PQM in a new page and we will implement on it the Pythagoras theorem. What is the length of QM? BM is 25. PQ is 10. So QM equals to BM minus BQ. So QM in total equals to BM, that is 25, minus BQ, that is 10. So QM in total equals to 25 minus 10, that is 15. So QM equals to 15 units in its length. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is right triangle PQM that are coming from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle PQM, it means that PM squared, that is the square of the hypotenuse, must be equal to PQ square plus QM square. PM is the missing side, so leave it as it is. So it is PM square equals to PQ square. PQ is 20, therefore PQ square is 20 squared, that is 400, plus QM square. QM is 15, therefore QM square is 15 squared, that is 225. So in total we should find out that PM square equals to 400 plus 225. 400 plus 225 equals to 625. So in total we shall find out that PM square is equal to 625. So here we take a root out of this equation and finding out that PM, the length of the missing hypotenuse PM, is equal to the square root of 625, that is 25. So the missing side PM equals to 25 units in its length. This is the missing side PM, is equals to 25 units in its length. So in the next step, we prove that those two right triangles can go into each other according to angle side angle rule. Side PM of this right triangle PQM equals to 25 units in its length. Likewise, and it is the hypotenuse, and it is equals to side MC of this triangle MNC. It also equals to 25 units in its length. So those two sides, they are both equal to 25 units in its length. those two angles are both equal to alpha and therefore they are equal to each other. Likewise, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. So actually proved that those two angles and the side that is included between those two angles, that is side PM in this right angle PQM, are correspondingly equal to those two angles, and the side that is included between those two angles, that is side MC, on this right angle MNC. And therefore those two right angles can go into each other according to angle side angle rule. We have those two angles and the side that is included between those two angles, that is side PM in the right angle PQM, corresponding equal to those two angles, and the side that is included between those two angles, that is side MC, in this right angle MNC. And therefore those two right angles can go into each other according to angle side angle rule. So I wrote it down. And she found out that this is the right angle PQM, and it's congruent. This is the sign of congruent to this right angle MNC, according to angle side angle rule. Again, she found out that the right angle PQM congruent to the right angle MNC according to angle side angle rule. And from the fact that those two right angles can go into each other, we derive those two sides must be also equal to each other in their lengths. According to the rule that corresponding sides in congruent triangles are equal to each other, those two triangles can go into each other, and therefore those two corresponding sides must be also equal to each other in their lengths. But side PQ equals to 20, therefore side MN must be also equal to 20 units in its length. Why those two sides are defined as corresponding sides? Because both of them are located in front of this angle, that is 90 degrees minus alpha. So PQ equals to 20, therefore MN must be also equal to 20 units in its length, according to the rule that I mentioned, that corresponding sides in congruent triangles are equal to each other. So MN equals to 20 units in its length. Likewise, those two sides are defined as corresponding angles, as corresponding sides, because both of them are located in front of this angle, that is alpha. Therefore, corresponding sides in congruent triangles are equal to each other. Those two sides that are corresponding sides are they are in these two right angles. Those two right angles can go into each other, and therefore those two corresponding sides must be also equal to each other and their lengths. But QM equals to 15, therefore NC must be also equal to 15 units in its length. We already found out that quadrilateral PMND is a rectangle, but we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PMND, side PM equals to the opposite side DN, but PM is 25, therefore DN must be also equal to 25 units in its length. Likewise, according to the same rule, in the same rectangle PMND, side MN must be equal to the opposite side PD, but MN is 20, therefore the opposite side PD must be also equal to 20 units in its length. PD is X, so X equals to 20. X equals to 20. This is also X, therefore it must be also equal to 20 units in its length. So we actually found out all the side lengths of this quadrilateral ABCD. The only side length that is left to find is AB, because we know that BC in total equals to 10 plus 40, that is 50. This is side DC. Side DC in total equals to 25 plus 15, that is 40. And finally, this is side AD. AD is 2x. X is 20, so 2x is 2 times 20, that is 40. So in total, the perimeter of quadrilateral ABCD equals to 50 plus 40 plus 20 plus this missing side. 50 plus 40 is 90, and 90 plus 40 is 130. 130 plus the missing side AB, in total it is equals to the perimeter of this quadrilateral ABCD. So we have to find out only the length of side AB. That is the missing length. Okay. So here we will use a new rule. The new rule will define the trapezoid mid-segment theorem. If a line segment connects the midpoints of the legs of the trapezoid, then it is parallel to the bases, and its length is equal to half of the sum of the lengths of the bases. So in the drawing we have trapezoid ABCD. AB is parallel to CD. AB and CD are defined as the bases of this trapezoid ABCD. AC and BD are the legs of this trapezoid ABCD. Line segment EF bisects those two legs. That is to say, point E bisects AC. If E bisects AC, it means that A equals to EC equals to AC over 2. Likewise, point F bisects BD. If point F bisects BD, it means that BF equals to FD, and each half must be equal to BD over 2. And according to trapezoid mid-segment theorem, the following equation is true. What is the length of segment EF? Segment EF equals to AB plus CD over 2. Again, segment EF equals to AB plus CD over 2. AB plus CD is the sum of the lengths of the bases over 2. Okay, so EF in total equals to the sum of its bases, that is AB plus DC over 2. We use the new formula in order to find out the length of PM. We already know that PM equals to 25. So according to mid-segment theorem, we get that, first of all, PM bisect AD. Why PM bisect AB? Because at point P, AD is being bisected into two halves. The first half is AP, this is equals to X. The second half is PD, this is also equals to X. So at point P, side AD is being bisected into two halves. Likewise, at point M, side BC is being bisected into two halves. Why? Because we already found out that BM equals to MC equals to 25. So in total, we can conclude that PM is the mid segment of trapezoid ABCD. First of all, quadrilateral ABCD is a trapezoid because AB is parallel to DC. Actually, it is a right angle trapezoid because those two angles are both right angles. So in the right angles trapezoid ABCD, PM is the mid segment that bisects AD and BC. And according to the mid-segment theorem, the length of PM equals to the sum of its bases, that is to say, it is AB plus DC divided by 2. And again, according to the mid-segment theorem, the length of PM that bisects AD and BC is equals to the sum of its bases, that is AB plus DC over 2. Again, PM equals to AB plus DC over 2. We already know that PM equals to 25, so we'll substitute PM by 25. And it is equals to AB. AB is the missing side, so we leave it as it is. Plus DC. DC in total equals to DN, that is 25, plus NC, that is 15. 25 plus 15 is 40. So DC in total equals to 40. AB plus DC, that is 40 over 2. So in total we found out that 25 equals to AB plus 40 over 2. Here we multiply this equation by 2 and find that 25 times 2 is 50, so 50 equals to 40 plus AB. Here we will subtract 40 from this equation and finally get that AB equals to 50 minus 40 is 10. So AB equals to 10 units in its length. So AB equals to 10 units in its length. We already found out that BC plus CD plus DA is 130. So 130 plus AB that is 10 is 140. So in total we found out that the perimeter of this trapezoid ABCD is equal to 140 units in its length. So it is done, we found out that the perimeter of trapezoid ABCD is equal to 140 units in its length. In the next step, I will present you another way to find out the length of side AB of quadrilateral ABCD. In order to find out in the second method the length of side AB, we will do a construction, that is to say from point B we will draw perpendicular on PM. Again, from point B we will draw perpendicular on PM. So actually this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point B and PM. This point is point S. By doing this construction, we get the quadrilateral PSBA. In quadrilateral ABPS we have one in quadrilateral ABSP we have 1, 2, 3 right angles, and therefore this fourth angle must equal to 90 degrees in its size, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So quadrilateral ABPS has 4 right angles, and therefore it is a rectangle. Quadrilateral ABPS is a rectangle because it has 4 right angles. This is triangle BSM. It can go to this triangle MNC. So why those two triangles can go into each other? First of all, BM equals to MC equals to 25. The hypotenuses of those two right triangles are both equal to 25, and therefore they are equal to each other. Likewise, in this triangle, right triangle BSM, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees, and therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So in those two triangles, we found out that the hypotenuses of those two right angles, they are both equal to 25, and therefore they are equal to each other. Likewise, those two angles are both equal to alpha, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So we should found out that those two angles and the side that is included between those two angles, that is side BM, in this right triangle BSM, are corresponding equal to those two angles, and the side that is included between those two angles, that is side MC, in this right triangle MNC. Therefore, those two right angles can go into each other according to angle side angle rule. So I write it down. We actually found out that the right triangle BSM, this is the right triangle BSM, can go to this right triangle MNC according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that those two sides are also equal to each other according to the rule that corresponding sides that can go into triangles are equal to each other. Those two triangles can go into each other, and therefore those two corresponding sides must be also equal to each other in their lengths. But NC is 15, and therefore SM must be also equal to 15. So SM equals to 15. PM equals to 25. We only found out that PM equals to 25. So PM minus PS, PM minus SM equals to PS. Again, PS in total equals to PM minus SM. So PS in total equals to PM, that is 25, minus SM, that is 15. 25 minus 15 is 10. So in total we found out that PS equals to 10 units in its turn. So in rectangle ABSP, PS equals to 10. But we know that the opposite sides of rectangle are equal to each other. So in rectangle ABPS, side PS must be equal to the opposite side AB. But PS equals to 10, and therefore the opposite side AB must be also equal to 10 units in itself. So we proved in two different methods that AB must be equal to 10 units in itself. And the perimeter of this trapezoid, right angle trapezoid ABCD is equal to 140 units in its length. So in the next step, I'll start the lecture. Our task in this question was to find out the perimeter of this quadrangle ABCD. The perimeter of any quadrangle is equal to the sum of its four side lengths. In this case, this quadrangle ABCD, it must be equal to AB plus BC plus CD plus DA. It is given us the question that those two angles are both right angles. You know that AP equals to PD, PQ equals to 10, QC equals to 40 units in its length. QC equals to 40. Likewise, this is also a right angle. Angle PQC is also a right angle. Again, our test is to find out the perimeter of this quadrangle ABCD that is equals to the sum of its four side lengths. So, in the first step, we did the construction, that is to say, we drew perpendicular on AD at point P. Again, at point P, we drew perpendicular on AD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. Then we extended the perpendicular from point P until it touches side BC. We define the touching point of the extended perpendicular from point P and BC. This point is point M. So those two angles are defined as one-sided interior angles, and the sum of those two angles is of course 180 degrees. And according to rule 18, if the sum of two one-sided interior angles is equal to 180 degrees, then they must be located between two parallel lines. That is to say, AB is parallel to PM. Likewise, the sum of those two one-sided interior angles is equal to 180 degrees, and therefore they must be located between parallel lines. That is to say, PM is parallel to DN, to DC. Likewise, the sum of those two one-sided interior angles is also 180 degrees, and therefore they must be located between parallel lines. That is to say, AB is parallel to DC. So in total, we should find out that AB is parallel to PM is parallel to DC. We should find out that AB is parallel to PM and it's parallel to DC. So all the three line segments A, B, PM, and DC are parallel to each other. And whenever you have three or more parallel lines that are connected together by line segments that are not parallel to each other, here AB is parallel to PM is parallel to DC. The three parallel lines, that is to say AB and PM and DC, are connected together by line segment AD. Likewise, they are also connected together by line segment BC. So AD and BC are connecting together the parallel lines AB, PM, and DC. And according to the basic proportionality theorem, special relationship exists between the two line segments AD and BC that connects the three parallels together. The following relationship exists between AD and BC. AP over PD equals to BM over MC. Again, AP over PD equals to BM over MC. And again, according to the basic proportionality theorem, the following relationship exists between AD and BC. AP over PD equals to BM over MC. We define, because of the fact that AP is equals to PD according to what is given in the question, we define the length of AP as x, and therefore PD must be also equal to x because they are equal to each other. So AP is x and PD is also x because they are equal to each other. And it equals to BM over MC. So in total we found out that x over x equals to BM over MC. X over x is 1, so 1 equals to BM over MC. Here we multiply this equation by MC and finally found out that MC equals to BM. MC equals to BM. BM equals to MC. That is to say, at point M, BC is been bisected into two halves. The first half is BM, and it is, of course, equals to the second half of BC, that is MC. Each half, of course, must be equal to BC over 2. And again, at point M, BC has been bisected into two halves. The first half, BM, of course, must be equal to the second half MC. Each half, of course, must be equal to BC over 2. But BC, what is the length of BC? BC in total equals to BQ, that is 10, plus QC, that is 40. So in total, BC equals to 10 plus 40, that is 50. Again, BC in total equals to 10 plus 40, that is 50, and 50 over 2 is 25. From this long equation, we will derive that BM equals to MC equals to 25. BM equals to 25 units in its length, and MC also equals to 25 units in its length. In the next step, I copied the right triangle PQM in a new page and implemented the Pythagoras theorem on this right triangle PQM. But before that, what is the length of QM? From the drawing, it is very easy to see that QM in total equals to BM minus BQ. Again, QM equals to BM minus BQ. So QM equals to BM, that is 25, minus BQ, that is 10. So in total, QM equals to 25 minus 10, that is 15. And again, QM equals to 15 units in its length. So in the next step, I copied the right triangle PQM in a new page and implemented on this right triangle PQM the Pythagoras theorem. This is the right triangle PQM that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle PQM, it means that PM squared, that is the square of the hypotenuse, equals to PQ squared plus QM squared. PM is the missing side, so we leave it as it is. So it is PM squared equals to PQ squared. PQ is 20, therefore PQ squared is 20 squared, that is 400. Plus QM squared. QM is 15, and therefore QM squared is 15 squared, that is 225. So in total PM squared equals to 400 plus 225, that is 625. So PM squared equals to 625. Here we took out of this equation and finally found out that PM, the missing hypotenuse PM, is equals to the square root of 625, that is 25. This is the missing side PM, that is equals to 25 units in its length. In the next step, we did a construction that is to say from point M we go perpendicular on DC. Again, from point M we go perpendicular on DC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point M and DC. This point is point N. We define this angle as alpha. So in the right triangle PQM, this angle equals to alpha. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Y equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. It is the sum of the angles in a triangle. So this missing angle, this first missing angle must be equal to 90 degrees minus alpha in its size. in quadrilateral PM and D we have 1, 2, 3 right angles, and therefore this fourth missing angle must be equal to 90 degrees in its size, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So in quadrilateral PM and D we have 4 angles, and therefore it is a right angle. Quadrilateral PM and D is a right angle because it has 4 right angles. So we have rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. So if we focus on the right side of the straight line BC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the right side of the straight line BC at point M? We have 90 degrees minus alpha plus 90 degrees is 180 degrees minus alpha. So 180 degrees minus alpha plus the missing angle in total must be equal to 180 degrees. Therefore this missing angle must be equal to alpha, because 180 degrees minus alpha plus alpha is 180 degrees. That is the sum of the angles on the right side of the straight line BC at point M according to rule 3. Therefore this missing angle must be equal to alpha degrees in its size. So in the right angle M and C, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in a triangle. Therefore this first missing angle must be equal to 90 degrees minus alpha. In the next step we prove that the right angle PQM, this is the right angle PQM, that it can go into this right angle M and C. So why those two right angles can go into each other? First of all, the hypotenuse PM in this right angle PQM is equal to the hypotenuse MC in this right angle MNC. They are both equal to 25 and therefore they are equal to each other. Likewise, those two angles are both equal to alpha and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. So I shall prove that those two angles and the side that is included between those two angles, that is side PM, in this right angle PQM, corresponding equal to those two angles and the side that is included between those two angles, that is side MC, on this right angle MNC. Therefore, those two right angles can go into each other according to angle, side angle rule. And for the fact that those two right angles can go into each other, we know that those two sides must be also equal to each other. According to the rule, that corresponding sides can go into angles are equal to each other. Those two right angles can go into each other, and therefore those two corresponding sides must be also equal to each other and their lengths. But PQ is 20, and therefore MN must be also equal to 20 units in its length. Likewise, QM must be equal to NC according to the sum rule, that corresponding sides and can go into angles are equal to each other. But QM equals to 15, and therefore NC must be also equal to 15 units in its length. So in rectangle PMND, side PM must be equal to the opposite side DN, but PM is 25, therefore the opposite side DN must be also equal to 25 units in its length. So today we found out that DC equals to 25 plus 15, that is 40. Here AB is the missing side, and we already found out that PM equals to 25 units in its length. In the next step, we implemented the trapezoid mid segment theorem on this trapezoid ABCD. Why ABCD is a trapezoid? Because AB is parallel to DC. So trapezoid ABCD, line 7 PM bisect AD. Why line 7 PM bisect AD? Because at point P, AD has been bisected into two halves. The first half is AP, and it is of course equals to the second half, that is PD. Each half equals to X, and each half must be equal to AD over 2, that is 2X over 2, that is X. Likewise, PM bisect BC. Why PM bisect BC? Because M is the midpoint of BC, because BM equals to MC. So M is the midpoint as BC. That is to say, line segment PM bisect AD and also BC. Therefore, we can implement here trapezoid mid-segment theorem. According to trapezoid mid-segment theorem, PM equals to AB plus DC over 2. And according to trapezoid mid-segment theorem, segment PM bisect AD and BC, the two sides that are not parallel to each other. That is to say, PM bisect the legs AD and BC of trapezoid ABCD. And therefore, we can implement here trapezoid mid-segment theorem. According to the trapezoid mid-segment theorem, PM equals to AB plus DC over 2. And again, according to trapezoid mid-segment theorem, the following equation is true, that PM equals to AB plus DC over 2. PM, we will found out that PM equals to 25. AB is the missing side, so we leave this it is, and DC equals to 40. And again, PM equals to 25, AB is the missing side, so leave it as it is, DC equals to 40 divided by 2. So in total, we found out that 25 equals to AB plus 40 over 2. If we multiply this equation by 2, we found out that 2 times 25 is 50. So 50 equals to 40 plus AB. Here we subtract the 40 from this equation, and finally found out that AB equals to 50 minus 40 is 10. So AB equals to 10 units in its length. So we found out all the side lengths of this trapezoid ABCD. AB equals to 10, AD equals to 20 plus 20, that is 40. DC equals to 25 plus 15, that is 40. And finally BC equals to 10 plus 40, that is 50. So BC, that is 50, plus DC, that is 40. 50 plus 40 is 90. Plus AD, that is 40. 90 plus 40 is 130. 130 plus AB, that is 10, is 140. So in total, we found out that the perimeter of this right angle trapezoid ABCD, in total it is equal to 140 units in its length. In the next step, I presented to you a second method to find out that AB equals to 10 units in its length. Why AB is equal to 10 units in its length. In this first method, we used the trapezoid mid-segment theorem in order to find out that AB is 10. In the second method, we did from point B we do perpendicular on PM. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PM, this point as point S. By doing this construction, we can do it for diagonal ABSP. For diagonal ABSP, we have 1, 2, 3 angles, and therefore this fourth angle must be equal to 90 degrees in size according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees, and therefore this fourth angle must be equal to 90 degrees in size. So for diagonal ABSP is 4 angles, and therefore it is a rectangle. In this right triangle PSM, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees, and therefore this third missing angle must be equal to alpha. Why? Because alpha minus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. It is the sum of the angles in a triangle. According to rule 3, this angle equals to alpha, and according to the rule, the sum of the angles in a triangle is equal to 180 degrees. The third missing angle must be equal to 90 degrees minus alpha. Those two right angles can go into each other according to angle side angle rule. That is to say, the hypotenuse BM of this right triangle BSM is equal to the hypotenuse MC of this right triangle MNC. They are both equal to 25, and therefore they are equal to each other. Those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. And finally, those two angles are both equal to alpha, and therefore they are equal to each other. So actually prove that those two angles and the side that is included between those two angles, that is side BM, and this right triangle BSM are corresponding equal to those two angles and the side that is included between those two angles in this right triangle MNC. Again, those two angles, and the side that is included between those two angles, that is side BM, and this side again BSM, corresponding equal to those two angles, and the side that is included between those two angles, that is side MC on the triangle MNC. And therefore, those two right angles can go into each other according to angle side, angle rule. And again, we found out that the upper right triangle BSM can go in, this is the side of congruent to the lower right triangle MNC according to angle side, angle rule. And from the fact that those two right triangles can go into each other, we will derive that NC is equal to SN. According to those, the corresponding sides and congruent triangles are equal to each other. But what is the length of SN? SN in total equals to PM, that is 25, minus SN in total equals to PM, that is 25, minus SM, which we found out that according to the Pythagoras theorem, PM equals to 25, PM equals to 25 units in its length. We already found out that NC equals to 15 units in its length. So side NC equals to side SM. But NC is 15, therefore SM as also equal to 15 units in its length. According to the corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say NC and MS, must be equal to each other and their lengths. But NC is 15, therefore the missing side SM must be also equal to 15 units in its length. So in total, PS must be equal to PM minus SM. PM is 25, SM is 15, so 25 minus 15 is 10. So PS in total must be equal to 10 units in its length. So in this rectangle ABPS, the opposite sides must be equal to each other. That is to say, side PS must be equal to the opposite side AB, but PS is 10, therefore the opposite side AB must be also equal to 10 units in its length. So we found out in two different methods that AB must be equal to 10 units in its length. So in total, the perimeter of this right against the trapezoid ABCD is equal to 140 units in its length. Okay, thank you very much.